Welcome back to Creating Stuff with Jim. I'm Jim, and it's time to create something. In this episode, I'm going to make a small modification to my backhoe. A couple of months ago, I had to lift a concrete pipe, and I didn't have any good lifting points on the backhoe itself to lift it. So it's a little hard to get a chain on there. So what I'm going to do is I'm going to add a lifting point on the bucket or close to there of my backhoe, so it's going to be a lot easier to lift things. And the one thing we're going to do different in this video is because I plan to build these parts out of 1/2-inch plate steel, and as of right now I don't have any, and the parts I got to make are rather small, so I really don't feel like going to buy a large piece of steel in order to cut out two small parts. So in this episode, I'm going to design the parts on CAD. I'm going to send them off to an online service where they're going to get cut out with either a laser or a water jet, and then they're going to get shipped to me. So I'm going to show you all the steps and everything involved in doing that. So without any more, let's get into it, and I'm going to show you what we got to do. Alright, so here we are out at the end of my backhoe, which, keep in mind, this is actually a very small backhoe. This is actually a 3-point hitch backhoe that was never meant for this tractor, but I made mounts to mount it so it works. Is right here, and what my plan is this is a D-ring shackle, whatever you want to call it, and basically I want to make a mount where I can pin this right here. And so what I'm going to end up doing is I'm going to cut a piece of 1/2-inch plate. It's going to be about as wide as this. I think it's going to be about 4 inches long than what I've already designed. And then after I weld that on, then I'm going to actually have a tab with a hole to put the shackle in. So I think that should work pretty good. And the reason I'm putting a plate on here is because this is not long enough. And so once again, I'll add another plate to stiffen this piece up that much more, and then put the tab on to hold the shackle. So but that's the plan anyways. And the biggest reason why I want to use a shackle rather than just putting something like this, I could just weld a grab hook on there, but what I want to do is with a shackle I have more options. I can use chain. If I use a strap, I can put strap on there. So depending on what I'm doing, putting a mount for this on there will give me a little bit more versatility. But still, when I say versatility, this backhoe really can't lift a whole lot, so it's only going to lift but so much. So I think that should work out well. So all right, well, now that I showed you the plan I got, now we got to jump on the computer. I'll show you what I got drawn up, and we're going to send that off because it's going to probably take a couple of weeks to get the parts, and we're going to go from there. So I'll see you when I get in on the computer. All right, now that we're on the computer, the first thing we're going to do is we're going to pull up Fusion 360, and I already have my file open. These are the two parts that I need for the lifting ring for the backhoe. So this is the eyelet. This is the piece that the shackle is going to go through, and it is going to be welded onto this piece. This is just a square piece of 1/2-inch steel that's going to be welded onto that one bracket. So anyways, so now we got those. Now we have to save these sketches into a DXF file. So what we're going to do is, this is sketch 1, which that's the ring. Sketch 2, that's the plate. So we're going to right click on sketch 1. We're going to come down and click save as DXF. So so now I'm going to select my folder, which have a dedicated folder for DXF files just to stay organized, and I'm going to give a quick name, lift ring 1. This is not doesn't have my normal number filing system just because it's under a very large project of the backhoe. So save that. All right, so that's now saved. So now, then I'll go to Sketch 2. We're going to save as a DXF file. And it's still going into the DXF folder. And we're going to call this one Lift Ring 2. And click Save. Now they're both there. We're going to go ahead, close Fusion 360, and here's our DXF file. And they're both there. Perfect. That's excellent. Now that I have my DXF file saved in a folder, now go to your web browser, and there's numerous online services that do laser cutting and water jet cutting and so forth. But the one I use is SendCutSend. I am not sponsored by them, not sponsored at all, but they have treated me right, have done very well, so I've been very happy with them, so that's why I still use them. So you gotta log in or create an account. Now these are other projects that I have worked on. So, but I'm going to add them to my backhoe file. So you come up here and you click Add Drawing, and Desktop, and then you just select your files. And some of the other files you see in here might be something you might see on the channel at one point or another. Just a tease. So, alright, so we've loaded the drawing, and when you see your drawing up here and it's shaded in gray, that means there's no real issues with it. You're good to go. If it doesn't show up completely shaded gray, that generally means there's an issue in it. You might have a double line somewhere, and if there's an issue, they'll kick it back to you and tell you what the problem is so you can fix it. But maybe another video I'll show you the ins and outs of that. So our unit of measurement is inch. We're going to keep that, and we're going to confirm that. Now we're going to select the material. So we're going with a metal. We're going with steel, just a plain hot rolled mild steel. We're not doing anything fancy. And the thickness that we're going is a 1/2 inch. So now, and we only need one of them, so you can see right here is basically for that one it'll cost $14.52. Click Next. We're not getting any other services that they offer on it, so I haven't tried many of these. I've just mainly used them for cutting stuff out. And then you click Next, and I'm not doing a finish. They do offer plating and all that. I have had some parts, some aluminum parts anodized. Actually came out pretty decent, but this is just plain cut out, deburred, ready to go. So anyway, so we're going to add that to the cart, and we got to add the other drawing. So go back up here, add drawing again. We're back in the same folder. Lift ring 2. We're going to select that. And it comes up simple square, but once again, these are small parts, and I don't have any 1/2 inch plate, so this is just a lot easier for these small pieces to do it this way rather than go buy a lot of metal for a couple small pieces. So once again, we're going to confirm that we're an inch. Confirm. We're going to do metal, steel, hot rolled mild steel, and then 1/2 inch. And then this piece is going to cost $21. Click Next. Next again. And no add-ons. Add to cart. And now we're going to view cart. Alright, so here we go. And so this is our cart. These are our 2 parts. and we're getting one of each. You can alter the quantity as needed. So and it even says it even gives a date where it's going to tentatively ship it. So and it gives us a total at the bottom. So that's not bad. That's not bad at all. Which, if I had a bunch of half-inch plate lying around the shop, I'd already would have cut these out with my plasma table and been done with it. So, but the other side of it is the neat thing is I get to share this with everybody on how to use these online services. So, like I said, just you can use a free CAD software and upload this, and you can get professional parts. I mean, very easily. Then you click your shipping, which we get free shipping. Like I said, it generally where I live, it takes them about 2 days to get here. So like I said, it's not real bad, but generally with the lead time, it generally takes about 2 weeks. But if you're working ahead, that's not an issue. So, but we're not overnighting that. We're just doing free shipping. Hit continue. Then select whatever payment you want to use. Then you come all the way down to the bottom and click place your order. And that's it. So that really wasn't that hard. That was actually pretty easy. So now this project is going to as a matter of fact, that ding you probably just heard, they just sent me a text message saying that they have received my order. So, but now we're gonna put this project on pause for a little bit. I'll end up putting clips in the video of all the notifications. It's actually pretty neat. They give you text messages and they give you progress the on how your parts are moving through their system. Very very professional, excellent. I highly recommend them. So, anyways, so now we're going to close all this out. We're going to jump off the computer and we're going to go do some. I'm going to go do something else. And when the parts come in, I'll bring you back to show you what it looks like when I receive them, and we'll finish it off. So. These are just a few screenshots that I took on my cell phone of the progress reports that SendCut Send will send you about your parts. They're very simple, as they've just received your part, they're reviewing them, they are in production, and they'll even tell you when they go into their final inspection. And then when they're 100% done, the last message they'll send you is that it has actually shipped, and then they'll give you a tracking number so you can track it. Well, and then now I came home from work one morning, and what do I find on my doorstep? But I got a package, and this is a package from SendCut Send. Let's go see what it looks like. They send you a piece of candy if you want it. And here are the parts that I ordered. I gotta tell you, the quality of this just looks absolutely gorgeous. The cuts are nice and square. They're all deburred. That looks really nice. And once again, and I know I could have just gotten a piece of flat bar, and there's a lot of other ways. This is just simple. I really didn't have to get this piece of metal, but the reality of it is, I didn't have to buy a whole piece of flat bar, and these two pieces didn't cost me a whole lot of money. I mean, it was I think it was like I'd have to look it up to see exactly how much they were, but it only took about 2 weeks to get them, so that's great. So this piece, the tab gets welded on like that right there. Then this piece gets welded onto the backhoe, and the D-ring goes in that hole. But this stuff looks great. So, well, I'll tell you what, now I got to find the time so I can weld these together and weld it on the backhoe and get it all finished up. But like I said, that so far this is pretty easy. I mean, in all honesty, it's really easy. So, all right, well, let's get to work. All right, now that I got the backhoe all set up on the sawhorse where I can easily work on it, weld on this. Still got to clean this up a little bit, get a little shiny metal up here. And this is how I was planning on placing my parts. Is the flat plate was going to get welded on here like so, and then the tab gets welded on here like that. And then after I get it all welded on, I go test it. I'm going to show you some of the different ways I can use it. So if it looks a little confusing, just give me a couple of minutes, I'll show you. So, and then also to go with kind of the theme on how I was trying to show you that you don't have to have expensive tools to do fabrication like this and still do it relatively easy, meaning I did not use my CNC plasma table for this. I actually sent them out to a service. The biggest thing you really need to understand and use CAD, and I showed you how all that worked in this earlier in this video. So as you might have seen, I have my share of welders, which it's funny, when I worked professionally as a mechanic, I always said I was a professional mechanic, but I was a welder as a hobby. So, but instead of using some of my expensive welding machines, I'm going do this old school. I'm going to stick weld this. So rather than using my MIG, TIG, or anything like that, I'm just going to do an old-fashioned TIG weld. I mean, I can't even speak right. I'm going to do an old-fashioned stick welding. So I'm using a 6013 rod. It's a 5/32 in diameter. And the reason I'm using a 6013 is because the machine I'm using is an AC machine. And actually, I'm going to go, before I clean this up, I'm going to take you in the shop. I'm going to show you the machine I'm going to use. I'm going to show you the welding machine I'm going to use. Alright, this is the welding machine that I plan to use today. This is just a simple AC buzz box. Runs off of 220 stick welder. And the quick story behind this welding machine is this is the very first welder I bought myself. I bought this back in my early 20s. This is back in the mid 90s, and I paid all of $200 for this thing, brand spanking new. So, but I have built so much stuff with this. I'll show you a picture of my big red Toyota, which you might have seen in one of my other videos. This welder built that entire truck. It built the front bumper, the Nerf bars, the flatbed. It built everything. So don't think that you have to have a big expensive welder to build anything. You can do it. Like I said, this is a very cheap welder. I've had it forever, and I haven't used it in a while. Every time I use this, like running into an old friend, so it's pretty neat. So once again, so we're doing this project kind of with kind of the simplest technology we got, or some of the cheapest, really. So anyways, and then actually one quick real funny story about this is because when I bought this, I was actually living with my mother at the time, and I actually had to power it. I actually made an extension cord that would plug into a dryer outlet, and it was like a 20-foot extension cord so it could reach into the house. And so I'd unplug the dryer so I could run my welding machine out in the garage. And I guess you could say I was less than responsible. When I'd unhook it, I wouldn't plug the dryer back in. My mother would get so angry at me because I didn't plug the dryer back in. So, but you know what? I think there's worse things to complain about in this day and time. So, well, enough of reminiscing. Let's go ahead and get this welded on and see how this turns out. So we gotta go clean it up, and we're gonna get back to work. Well, there you have it. It looks like this worked pretty well. The load test worked. It didn't break. My backhoe actually could lift more than I thought it would. It could actually at least it can lift a worthless engine. So this is working. I'm very happy with this. Now, is if you'll notice when I said I wanted to put this lifting eye in this particular spot, you saw how the first time I rigged it, the lifting eye can when you notice the first time that I rigged it, the lifting eye was the farthest point out, and you have good clearance where you can do good rigging and you can lift something. But the other reason why I wanted to put it here versus other places is on how I have it set up right now. If I need the maximum reach I can get, I still have a really good anchor point, and I can run the chains in between the teeth of the bucket, and I can get the maximum reach that I can get to have to lift something. So I'm very happy with this. This actually worked very, very well. So, but this will about conclude it for this project. So I hope you guys enjoyed watching it as much as I enjoyed building this. So this is going to give me a lot of good use for a lot of years to come. So, but anyways, but if you enjoyed my video and you're not subscribed to my channel, please subscribe to my channel. And once again, if you did enjoy it, please share it with your friends. So until next time, I'll see you later.